So welcome back to the final session of the UML diagrams. So far you have completed nearly 5 to 6 experiments about how the project should be, what are the basic requirements, and how you should able to project your project in terms of various UML diagrams. So you might have completed use case, class diagram, sequence, activity, but now we'll be ending the UML diagrams by going for the final session, that is nothing but the component and the deployment diagram. Okay, so till experiment number 3 to 7 will be based on the UML diagrams. So this is the final UML diagram for the software engineering lab. The remaining experiments will be based on real-time applications. Okay, so we'll be going for black box testing, white box testing, so on so. Okay, so in this particular experiment, you will be having the final idea about how the hardware, how the software is being run on the hardware. Okay, what are the different type of components that are available in order to design a system, and how that particular software is being run on that particular system we'll be discussing. Okay, so first of all, you should be able to know the difference between what is a component and what is a deployment. Okay, so the word component talks about how, what are the physical devices that are available for creating a system, to run the system, okay, to test the system. So these are nothing but the components, that is nothing but the hardware products. Okay, deployment is nothing but not actually deploying the project, but how that particular software or how that particular application is being run on that particular hardware. Okay, so this is the actual basic definition. So the component diagram, it models the physical view of the system. Okay, for example, if you have an idea of building your own PC, okay, personal computer, for designing a personal computer, what are the major components you need? You need a monitor, you need a keyboard, you need a mouse, you need a CPU. Okay, so these are the basic components needed for a personal computer. At the same time, you can add additional features. You can able to add the printers, other wireless devices, routers, so on, so etc. So depending upon the technology, depending upon the idea, you can able to visualize as well as you can able to have a clear physical view about the system, how it operates. Okay, if you talk about a system, normally a system will be having all the files, the executable files, okay, libraries, so and so etc. So every files, executables will be represented in a form of a node. Okay, node is nothing but a system. Okay, so if you take your own particular monitor, okay, if you install a particular game, what are the different types of executable files are available, folders are available, libraries are available. Okay, for a single application itself, you are having n number of features, n number of files. Okay, so for installing a particular game, installing a particular software, these are the different types of softwares being run in the hardware. Okay, so the implementation of the component diagram is totally hidden. See, for example, if you take your own CPU, okay, we may not have the knowledge how the CPU actually works. Okay, there is a motherboard, there will be a RAM will be there, a power unit will be there, so many things will be available, but we don't know where it actually begins, how it actually works. So it is a combination of electronics, electrical, all the embedded processing, all the embedded programming, everything will be inside. Okay, so it is like similar to a black box. So component diagram is nothing but similar to a black box. We doesn't focus on how it actually works, but we can able to project the physical view of how the system will be launched into the market. Okay, then the deployment diagram. Deployment diagram, it will be visualizing how the physical hardware of that particular system, the application runs. See, for example, if you take your own laptop, okay, it is a physical hardware device. Okay, the software is nothing but your operating system, how your operating system is being compatible, how your operating system is being run in your laptop. That is the final stage of the deployment diagram. Okay, so deployment diagram talks about how applications are being run in the hardware, whereas the component diagram discuss about the various components that are available to create a systems, and how it operates, that we don't need to focus. Okay, but what are the important things that are available inside each and every hardware, that we need to focus. Okay. So what are the notations for a component diagram? Okay, these are nothing but rules. So you need to draw a component diagram. Before drawing, you need to know the notations. What are the notations available? So a component is nothing but it's a single unit of a system. As I told, a CPU. A CPU is nothing but a central processing unit is nothing but it is a unit of a part of a system. It can be replaceable or it can be executable. Okay. Now replaceable executable means inside the CPU itself you have n number of devices. You have a RAM. Okay. If you want to increase the RAM speed, automatically what happens? You can replace the existing and you can able to place a new one. Okay. At the same time, it's also executable. Okay. An inbuilt processor or inbuilt software will be inside the processor. Okay. That can be executable and as well as it can be reconfigured. Okay, so you need to clearly identify what are the components that are available for the system, and you need to mention which are the components are replaceable as well as executable. Okay, so for a component, this is the notation how you draw a component. Okay, and for a node, or we can call this as a system, this can be rectified like a square box. Okay, so these are the two basic notations for drawing the component diagram. Okay, so we'll go for an example. We'll have an example for online shopping system. Okay, so for an online shopping system, you need to identify what are the actors, what are the things will be available. See, for buying a product through online, you will be the customer, the product what you're planning to buy. Now, through who you're planning to buy, either you'll be ordering through uh, Flipkart or Amazon or any other third party, okay, service which are available. Okay, so you can able to see the connection. The customer, he will be having he'll be entering the details, the name, the address, the bank details, so and so. So in order to purchase that particular product, the customer will be giving the details of that particular product, what he wants to order. So in the ordering process at the back end, it will be going and it will be searching the item code. Okay, so every item, every product will be having a code. Okay, it can be a barcode or can be a unique code. So with the help of that item code, it will be looking for that particular product. Okay, so this will be the front end and this will be the back end. Okay, once that particular product has been identified, automatically what happens, you can either add more to the cart or you can able to finalize the purchase. So automatically what happens, the customer, you will be having your own account. Okay, it will be a mutual connection. So here you can able to see this is an association. Okay, these are nothing but called as interface. Okay, so how you are ordering the product through the interface. So this interface, it can be either through a web browser or a mobile app. Okay, so this is nothing but an interface. Okay, so once you are planning to buy that particular product, automatically what happens, with the help of the account details, and you can able to see this is an interface. The interface will be connected to that particular order. Okay, then automatically the payment will start, payment start begins. Okay, the payment initialization, everything, OTP, okay, everything will be initiated. Okay, so this is an overview about how the component diagrams will be launched inside that particular physical view. Okay, so you can able to see that these are the nodes, these are the systems. Okay, customer is nothing but he will be either operating through his laptop or through a mobile phone. So that is why this particular rectangle box is given. So this is nothing but a node, it's nothing but a system. Okay, and you can able to see, and inside the customer system there is a component. Okay, so this component, it's nothing but a unit. Okay, so you will be using the web browser. The web browser is part of your particular device. So with the help of the web browser, you will be planning and you will be communicating to that particular server. Okay, Amazon server. And in that Amazon server, they will be having a backend server for that particular list of products. Then automatically with the help of the account, you will be purchasing that particular product. Okay, so this is how the component diagram should be. Now in this particular diagram, you can able to clearly see we are not worried about how the customer system will be. Okay, whether he is using a 8 GB RAM system or whether he is having a graphic card or whether what type of web browser. See, the point is the system is completely hidden. All you need to know is the physical attachment, how the system operates. Okay, so this is how the component diagram will be looking for this particular application. Okay, now some of the real world application for this component diagram. Okay, so whatever UML diagrams you have come across, so you should be able to know that whether it can be implemented in real time. Okay, so once you step into the IT sector and once you start designing projects, you need to choose which appropriate UML diagram is efficient to project it. Okay, so for a component diagram, these are the n number of following real-time applications. First one is nothing but a components of system. Okay, as I told before, if you want to lay out a PC, okay, so there will be a PC, keyboard, mouse, a CPU, printer, router, so and so, etc. Okay, we need not to worry about what are the configurations inside, but we can able to give a physical appearance of the components of the system. Okay, then you can able to model the schema of the database. Okay, so inside the database server, how many rows, how many columns will be there, and how the process of giving the values, how it's being stored, everything you can able to have a complete view. Okay, so inside the database you'll be having n number of database. So some of you have heard the word which is called cloud computing, or you might have heard the word cloud. It's nothing but it's a collection of server of servers. Okay, so this part you should be able to know. Then finally you can able to see application of an application, how it actually works. Then finally the system source code. Okay, so these are the n number real-time applications which are applied for the component diagram. Okay, so this is one part of the experiment, component diagram. Now moving on to the second part, it's the deployment diagram. So deployment diagram, as I told before, how the software it's being launched inside the hardware, that you need to clearly understand it. Okay, so the notation for this particular deployment diagram will be quite similar to your component diagram, but the only thing is you will be having two additional notations. Okay, so for a component diagram, the same component will be there for the deployment. Okay, the same pattern will be there, the same node will be there. The only thing is you'll be having an artifact. Okay, artifact is nothing but how the product is being developed by the software, and finally it will be represented like this. Okay, and we will be having an interface. So in the previous diagram you might have seen a circle, so that is nothing but the interface, how you are connected to that system, either through the web browser or through a mobile app. Okay, that's nothing but the interface. Okay, so these are the four major notations which are available for the deployment diagram. If you know these components, automatically you can design your own deployment diagram. Okay, so similar to the previous component diagram, we'll go for a real-time example. Okay, so this example talks about the application iTunes. Okay, Apple iTunes application. Okay, now some of you will be having your Apple mobile phone. Okay, you'll be having an iTunes, a separate server maintained to update your song list. You can able to download it, you can able to upload it, so and so, etc. Okay, but the point is you should know how it actually works. Okay, so here we will be having two devices. One, this particular device will be run in through your home laptop as well as your mobile phone. Okay, now you need to clearly understand how it actually works. Now if you take a mobile phone, you will be having a component which is called iPhone OS. Okay, so this is nothing but a part of your system, part of your mobile phone. Okay, you'll be having an operating system as well as you'll be having a media library. Am I right? So if you want to play a song, automatically what happens, your operating system will be boosted. Okay, it will be loaded, as well as you'll be having an inbuilt media library to support the music, the several features. Okay, the same thing if you talk about a PC, automatically you'll be having a web browser as well as an inbuilt library for that particular thing. Okay, so you can able to see that this particular media library and this particular media library are being synchronized. Okay, now imagine for your mobile phone you'll be having your Gmail, your personal mail ID, as well as for your laptop you'll be using your personal mail ID or Carnia mail ID. Why you are both logging? So that whatever you're browsing, whatever you've searched here, everything will be synchronized to your particular opposite device. Okay, so the history may be different, but the point is whether you're planning to save the password, whether if you are planning to save the page, automatically everything will be synchronized. So the same media library will be getting synchronized, whether you're updating the song or whether you're deleting, whether you're downloading, whatever. So everything will be synchronized. Okay, and you can able to see this arrow. It's nothing but part of. It is nothing but composition. Composition represents part of relationship. It means that media library, it is a part of the home PC or the mobile device. So this arrow represents part of. Okay, so a web browser is a part of being used in the system. Okay, so this is how you should able to match the arrows. Okay, now coming back to the application. Now you want to download a song or you want to upload it, you want to put a backup. So automatically what happens, you will be connecting to the iTunes server. Okay, so you will be having an application. See this particular green color, you can able to see this is a server. Okay, this is a server which is called Apple Web Server, and inside this Apple Web Server, through this particular website, how you accessed, okay, you will be having a system. Okay, you will be having a system which is called iTunes, and in that iTunes there will be a exe file. Okay, an executable file. So before this executable file is nothing but, if you want to run this iTunes in your mobile, I'm sorry, in your laptop, automatically you need this executable file in order to manipulate that particular playlist. Am I right? So what happens is, when you start running this application, okay, you can able to see this brings out another system, and in that particular system a media library will be there. So what happens is, when you start executing this exe file through the web browser for this particular device, automatically what happens, the media library will be synchronized and it will be uploaded to your iPhone OS, as well as it will be uploaded through the web browser, and it will be depending upon this particular PC. Okay, so these are nothing but how the actions are being taken. So you can able to find that how the system, how the software is being run in that particular system. So you can able to find we have an exe file. So exe is nothing but an application. How this application is run in this particular system, that is nothing but iTunes. So when you start clicking the exe file, automatically what happens, the application gets loaded. Automatically a media library will be installed in your inbuilt iPhone OS, as well as it will be connected to your PC. Okay, so whenever you use your playlist in a form of a PC through your PC, automatically what happens, this application will be depending upon the PC. Okay, so without this dependency, you can't able to access the iTunes server. Okay, so what happens is, whatever files you are executing, whatever files you are planning to modify or support, automatically everything will be depending upon the system, everything will be getting synchronized. Okay, if you tap or if you try to delete or if you try to modify any particular values, automatically what happens, everything will be changing here and there. Okay, so this is how you should able to draw the deployment diagram. Okay, so you can able to find this is the application. So exe is nothing but an application. How this application is being run in the hardware. Okay, how it's being run in the system. So this is how you should able to draw your deployment diagram. Okay. Okay, so this is the final real-time application for the deployment diagram. Okay, so whatever we discussed with the component diagram, quite similar will be available for the deployment diagram also. Okay, so for the component diagram, it will be focusing upon how the hardwares are being connected, but in the deployment diagrams, the same concept, and you need to mention where the software is being run in that particular hardware devices. Okay, so with the help of the deployment diagram, some of the real-time applications are to model the network and hardware topology of the system. Okay, so what happens is, you will be having your own system, okay, your own PC or your own laptop, everything connected through a router or through a printer, whatever. So in order to make the router function, you need a software. Okay, so you need a ISP software in order to make that particular router being connected to your system. Okay, so there will be an inbuilt application for that router to be enabled so that you can able to get the internet facility. Okay, so imagine for the first time you're buying a modem to get internet for your home. So just like that, with the help of the Ethernet cable plug-in, you can't able to get the internet. Once what happens is your IP address should be generated, that particular router should be active. In order to make that router to be active, we need to connect it, we need to install certain softwares, we should able to have certain conditions of how that particular router operates. Then only that application should be satisfied, then only you can able to access the internet. Okay, so there are certain rules of applications available. You need to mention what are the applications that are available. Okay, then we have distributed networks and systems. Okay, forward and reverse engineering. Okay, forward and reverse engineering, I think after your second interns you'll be learning what do you mean by forward engineering and reverse engineering. Okay, then hardware details for a basic client server system. Okay, so client server system is nothing but remote desktop. Okay, so there will be a system how your system should be connected to that server. Normally we'll be having our IP address, but no, there is something called remote desktop. So that remote desktop with a certain number of applications conditions you should able to apply in order to make sure your system is totally visible to the internet. Okay, so anytime the server can able to come inside, get the files, manipulate, and it can able to go. So what are the different applications that are available for in order to make a perfect client server system or a remote desktop system? Then modeling the embedded system. So there is something called embedded processor, embedded programming. What is those? Now, for example, you will be having your own processor, whether it's i5 or i7. Okay. So automatically every processor, whatever you're using, there will be a embedded programming available. So that embedded programming can be written in either C or Python or whatever language. You need to identify what is the goal of that particular programming written in the hardware. Okay, so these are some of the ways you should able to identify the applications, what are the things being run inside the hardware so that you can able to construct a deployment diagram. Okay, so with this, the UML diagrams for your software engineering lab is completely over. Okay, so the remaining 3 exercise or 5 exercise will be based on real-time implementation of how to develop your project. Okay, so all the best, and we'll be meeting.